this evening talking about the chain rule. So in this section, section 7, we are going to find the composition of two functions and then differentiate them using the chain rule. Okay. So a couple of definitions. This one right here goes back to our algebra days, but it's important to refresh our memories on those so that we can get through the chain rule itself. Okay. And so what we have is basically if you have two functions, and that is a function f and g, and you want to compose them together, you read this here as f of g, right? And so that really means that everywhere I see an x in my f function, I'm going to substitute in my entire g function. Okay. So let's look at this example I've given us here. If I have f of x cubed and g of x is 1 plus x, then what is the composition f of g of x? And we'll do the other way as well, right? So what is g of f of x? Okay, so that we can see how this is impacted. So first, let's do the one here on the left. So we have f of g of x. Again, that is just taking my f function, and everywhere I have an x, substitute in my g function. Okay. So in this case, I would be saying my g function is 1 plus x squared. So everywhere I see an x in my f function, I'm going to substitute that whole piece in. Okay. So my f function is x cubed, right? So, but everywhere I see an x, I need to substitute in this 1 plus x squared, but I'm going to leave that cubed on out there. And so when I factor that using FOIL, and I have to do it twice, right? Because I'll do 1 plus x squared times 1 plus x squared, get that, multiply it again by 1 plus x squared. I will end up with 1 plus 3x squared plus 3x to the 4 plus x to the 6. Okay, so my composition, if I substitute in my g function into my f function and simplify, that's what I'm going to end up with. Okay, now let's do it the other way where I'm plugging g of f of x, right? So that's saying everywhere I have an x in my g function, I'm going to substitute in my f function. Okay, so that's saying g of x cubed, because my f function is x cubed. So everywhere I have an x in my g function, I'm going to substitute in x cubed. And so that gives me 1 plus x squared. For the x, I'm subbing in this x cubed. So x cubed squared is x to the 6. Okay, so you can see that g of f of x is not the same as f of g of x. Okay, question. Okay, so now let's start talking about the chain rule itself then. So ultimately, that is taking the derivative of a composite. Okay, and so when we take the derivative of a composite, a composition of two functions, that is really, we could just say that it is my f prime evaluated at my g of x times g prime. Okay. Similarly, and we'll see these in example. Similarly, if I have down here, I have this extended power rule. Remember, we used the power rule in a couple of sections ago where we learned how to do those. But what happens if I am looking at a more complex function, right? And so we can do that as well by taking my k times my g function. My g function is raised to the k minus 1, And then I need to multiply out here by the derivative of my g function itself. Okay. And we'll look at a couple of examples of each of these types. Okay. So the first problem that we have here, oops, it looks like my 2 got erased off of that, is y equals 2x plus 1 squared. So for this first one, we're going to go ahead and use the extended power rule for this problem. So in using the extended power rule, we're just saying that dy dx is equal to the derivative of, I'm going to do 2x plus 1 squared. And so that is putting it in the similar format that we had over here, right? So we're just putting it in this format here. So we can determine what is our k, what is our g of x, and then we can do that relatively easy, right? So our k in this case is this 2, right? This here tells me that k equals 2. And this wrong color, this right here gives me my g of x, okay? So when I want to take the derivative here, then that's going to give me the derivative is going to give me 2 times g of x, that's 2x plus 1. And then this is 2 minus 1 times the derivative of the insides or the g function itself, okay? So we have one more step. We have to take the derivative over here of this 2x plus 1. So this right here is going to simplify down to 1. So this is 2 times 2x is 4x plus 2 times the derivative over here of this. The derivative of 2x is 2. Okay. The derivative of 1, it's a constant, so that is 0. So now I can simplify this here and I get 8x plus 4. So my derivative of this function raised to an exponent, right? So this is really the composition of two functions, right? If I had a function x squared and I had 2x plus 1, right? If this was my f function and this is my g function, then my f of g of x is really just that 2x plus 1 squared. Okay? So that's really what we did here. So that's why in the past we could, if I had x to the 5th or x to the 3rd or anything like that, it would have been very simple. We could have used the power rule. But because we have this, it's not that simple. It's something plus another value and then raised to an exponent. We have to use this extended power rule. Okay? Any questions? What I do want to do here now is just show you that we could check this by expanding. And we can do this for this problem because this is just 2x plus 1 squared. So that's 2x plus 1 times 2x plus 1, which equals 4x squared plus 4x plus 1. So then when I take the derivative of 4x squared plus 4x plus 1, I can use those techniques that we learned from the product rule now and see that that is 8x plus 4, which is exactly what we got by using the extended power. The reason we teach the extended power rule is there will be times when if I had something raised to the 15th power, you wouldn't want to do all of that multiplication out and then simplification. So it's much better to know how to use the extended power rule so that you can quickly work through some of those more complex problems. Okay, question. Okay, let's look at a more involved problem, right? So here is an example where we have the extended power rule in the numerator as well as the denominator, right? But we're also going to need to use our quotient rule, right? So we're going to do a combination of the extended power rule and the quotient rule here to get through this problem. So the first thing I always say, let's identify our f function, which is this 2x plus 3 raised to the fourth. And our g function is going to be 3x minus 2 raised to the fifth. Okay. So now when we take the derivative of each of those, we'll want to use the extended power rule to get at that solution. Okay. So my f prime then, using my extended power rule. So I'm gonna do two colors. So, sorry. Oops. Go to orange. So here my k equals 4, right? So we have 4, right? Times my function, which is 2x plus 3. And then this is 4 minus 1. So I'm going to just write a 3 up here. Okay. And I want to take the derivative of this. The derivative of the insides is just 2. Okay. So that's really what we did right here, is the derivative of the insides. But instead of writing that out every time, it's sufficient for you all to just write the 2. Okay. Any questions on that one? So our k in the denominator, our k is equal to 5. So our g prime equals k times the inside the parentheses function, which is 3x minus 2, k minus 1. So that's 5 minus 1 is 4. And the derivative of what's inside the parentheses is 3. So that is our extended power rule. Okay. Any questions so far? Okay. All right. So now we have to remember, what is our quotient rule? Remember, the quotient rule tells me that I have my gf prime minus fg prime divided by g squared, right? So, but now we have all the pieces that we need. We just have to put them into place and simplify. So my g function is 3x minus 2 to the fifth power. My f prime is, I'm going to put it in brackets so we have all of that. It's 4 times 2x plus 3 cubed times 2. We could have also did 4 times 2 and wrote 8 there. So let me go ahead and do that just to simplify it up a little bit. Okay. So that's the first piece. And I put a plus here, but it's multiplication. Okay. Minus off my f function, which is 2x plus 3 raised to the fourth, times my g prime. 5 times 3 is 15. And this is 3x minus 2 to the fourth. All of that divided by my g function, which is 3x minus 2 to the fifth squared. Okay. Any questions so far? Okay. Now what I want to do is I'm going to, I want to factor, I want to get out any common factors. So does this term and this term have in common, right? They each have a factor of 3x minus 2. Sorry, I erased that 4. Okay, so 3x minus 2, and we have a 3x minus 2 over here. So the next thing I want to do is look, I have this is an exponent of 4, this is an exponent of 5. So I want to factor out the one with the smallest exponent, right? So think of that in terms of if I had 10 something 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 minus a 5 something something something, right? I can factor a 5 out of each of those terms, and that would leave me with, I would have 5 multiplied by, it would leave me with 2 here, whatever else, minus 1 here, and whatever else. So that's the idea of what we're doing here, is we're factoring out all of the common terms. Okay. So I can only take the smallest common denominator that we have with them, right? Or the smallest common factor. So 4 is smaller than 5, so we can only pull 4 of them out. So that's going to be 3x minus 2 raised to the 4th power. Okay. I can also pull out a factor of 2x plus 3. Okay. So in these, I have an exponent of 3 and an exponent of 4. So I have to pull out the smaller one. So that's 2x plus 3 raised to the 3rd power. And then what's left here is the remainder, right? So if I look at this first term here and I say, okay, I pulled out 4 of the purple, that's going to leave me 1 of them left because I had 5 to begin with, right? And then I am going to be left with the 8. That 8's still going to be there. I'm going to just move it to the front because it's more proper to put the constants in the front. And the 3, the green, that goes away because I've already factored those out. And I could multiply it here by 1, but it doesn't matter because we have something else besides 1. If you don't have any, if you took all of the problem and factored it out, you would need to make sure and have a 1 as a placeholder, but we don't need that in this case. Okay. Now we're going to minus off whatever's left from this other term. So we're going to minus off, we still have that 15. Green, or the purple one, we took all of the purple ones out of this side, and we took all but 1 of the green terms. So that's going to leave us here with 2x plus 3. Okay. All of that is still divided by our denominator, which is 3x minus 2. However, instead of having it 5 raised to the 2nd, we can just do that as 10, because anything raised to an exponent is you just multiply those values, and that gives us 5 times 2 is 10. Okay? Question. We're not done yet. We have more simplifying to do. We need to simplify everything that is inside of this term here. So we could do so by distributing these constants to the things inside the parentheses. Okay. So let's just go ahead and rewrite the 3x minus 2 to the 4th times 2x plus 3 cubed times 8 times 3x is 24x minus 16 minus 30x minus 45. All of that divided by 3x minus 2 raised to the 10th. So we just have one more step of simplifying what is in our brackets here. Okay. So we end up with We have 24x minus 30x, so that gives me negative 6x. We have negative 16 minus 45, so that gives me minus 61. Okay. All right. And so we could leave this problem like that. Some textbooks don't like this here with the negative. So what it would do is it would say this is the same as saying negative 6x plus 61, and then just bring that negative x out here in the front. So it is possible that, oh, one thing that we can also do, yes, we'll bring that out. And then the other thing, if you notice, we have 10 of these 3x minus 2's in the denominator. We have 6 of them in the numerator. So these 4 would cancel with 4 of these and leave us with 6. Okay. So that would leave us with the final answer of negative 2x plus 3 cubed times 6x plus 61, all of that over 3x minus 2 to the 6th power. Okay, question. Okay, so now let's just look at another example. So in this case, you're given that y equals u cubed minus 7u squared, and you're told that u is equal to x squared plus 3. Okay. So the first thing that we can do is we can take the derivative of our y, but be careful because now that variable is a u and not an x. So because remember, we're used to writing dy dx because our variable's always been an x. But this time we need to write dy du because our variable is a u. Okay, so when we take the derivative of that, we end up with 3u squared minus 14u. Okay, if I take the derivative of u, that's du with respect to dx. Okay, and so the derivative of u is going to be 2x. Okay, now if I want to know what is my derivative dy dx, that's what it's asking me for, right? Dy dx is the same as saying dy du times du dy, du dx. So those counter with each other, and we're left with the dy dx, right? And so we can do that here. So my dy du was 3u squared minus 14u, and my du dx was 2x. Okay. Now I already know that this, it says that u is equal to this. So everywhere I have a u, I can substitute that back into my equation. And so that's going to give me 3 times x squared plus 3 squared. Let me make sure. X squared plus 3. Yep. So everywhere we have a u, we're going to substitute that in. So minus 14 times x squared plus 3 times the 2x out there. Okay. So if I came over here for side paper and I have x squared plus 3 times x squared plus 3, right? I'm just factoring that FOIL method that out. That's going to give me x to the 4th plus 3x squared plus 3x squared plus 9. So this here is 6x squared. Okay. So that's what that's going to give me there. And then if I take and multiply that by a 3 on top of it, right? So we have equals 3 times this x to the 4 plus 6x squared plus 9. minus, and then I can do the 14 here. So that's going to give me minus, I don't need the parentheses, minus 14x squared minus 42. I do need the parentheses because then that's times 2x. Okay. Actually, it's this whole thing. This whole thing should be multiplied by 2x. Okay. So when we multiply that all out, we end up getting 3x to the 4 plus 18x squared plus 27 minus 14x squared minus 42, all of that times 2x. Okay. And when we simplify the insides here, we can combine our 18x squared and negative 14x squared, and we can combine our plus 27 negative 42, and that's going to give us 3x to the 4 plus 4x squared minus 15, all of that times the 2x. Okay. And the one last thing that I would say is we can actually factor, because this right here is a perfect square. We have the 4 and the 2. We could actually factor that into, we'll move the 2x up to the front, and that's going to leave us with 3x squared minus 5 times x squared plus 3. Just as a quick refresher over here, remember, if you have two perfect squares or how you want to factor that, this is 3x squared squared plus 4x squared minus 15. So if you think of it in terms like that, then you can see that it factors out to the 3x squared minus 5, x squared plus 3. Okay. And you can, factoring obviously is something that you probably got out of algebra, maybe high school. So it could have been some time since you've seen that. So if factoring is something that you struggle a little bit with, you definitely want to just go look at some videos. Khan Academy has some great videos on factoring polynomials. If you have a hard time finding any good examples, shoot me an email and I'll help you find some as well. Okay. All right. Any questions on this kind of problem? Okay. So this is like number 50 in your textbook on page 172. This problem is looking at if you have f of u is equal to 2u to the 5, g of x is equal to u, which is equal to this 3 minus x over 4 plus x. And we want to evaluate the composition of this function's derivative at negative 10. Okay, so there's a lot of things going on here, and we just need to step through it one step at a time. So the first thing that we want to do, to not be confused with f and u and f of x and g of x and all of that, I'm going to call these functions. I'm going to call this first one, let's call it q. We'll call this function q and this function r, right? Because we're going to need to do the quotient rule on g of x. Okay. So we're going to say let q equal 3 minus x, and let r equal 4 plus x. Okay. So my derivative, q prime, is equal to -1, and my r prime is equal to +1. All I did was take the derivative of each of those. Okay, so my g prime, remember g prime is just my, it's going to be my r function. I wanted to put f g prime because that's how or gf prime. So this is going to be r q prime minus q r prime divided by r squared. Okay. So when we put all that in, we end up with 4 plus x times -1 minus 3 minus x times +1 divided by 4 plus x squared. Okay. That's going to simplify to -4 minus x minus 3 plus x over 4 plus x squared. And then lastly, we can combine like terms, and that gives us a -7. The x's cancel out with each other. We have a positive and a negative, and then we're left with 4 plus x squared in the denominator. Okay, so that's what my g prime of x is. Okay, and we need that as part of this problem, right? Because remember, the function or the theorem tells us for the extended power rule and for the chain rule, it tells us that d dx of f of g of x is equal to the derivative of f g of x, right? Which is equal to f prime evaluated at g of x times the derivative of g of x. Okay? So what does all of this mean? First, we have our f function, right? So this tells me that f prime of u, right? F prime of u is going to be, I'll put the u in parentheses, is 5 times 2, which is 10, u to the 4. Okay? Because we'll need that as part of our process as well. Okay. Any questions so far? Okay. So when we're looking at f prime of, so when we look at f prime of g of x, right? So what is f prime? We calculated f prime at 10. So f prime is 10 u to the 4, right? That's this f prime. But we're evaluating this with our g of x, right? So instead of u, we're putting, everywhere we see a u, we're putting our g of x. Okay, so this is the same as, this is 10u to the 4, but we're just substituting in g everywhere we see that u. Okay, question. And then we're multiplying by our g prime, which we calculated over here as -7 over 4 plus x squared. Okay. And now we just need to simplify. Okay. So one thing I will say is we can take this 4 exponent here And you can say that that's the same as 10 times 3 minus x to the fourth over 4 plus x to the fourth. Okay. And then we're multiplying it still here by this negative 7 over 4 plus x squared. So finally, what we can do is we have a common denominator here, right? So this is going to give us 4 plus x. 4 plus 2 is 6. So when they're multiplied by each other, you add the exponents. When they're raised to it, you multiply them. So in this one, we're just adding those two exponents. We can then take 10 times negative 7 is negative 70. And then 3 minus x to the fourth. Okay. So lastly, we want to evaluate this. The last part, it wanted us to evaluate f of g prime at negative 10. So we want to substitute in negative 10 everywhere in our formula here. And we get negative 70 times 3 minus negative 10 to the fourth divided by 4 plus negative 10 to the sixth. That's going to simplify down to negative 70 times 13 to the fourth over negative 6 to the sixth power. We could get a decimal approximation of about negative 42.9. Okay, question. All right, this is the last example from this section. This is number 64 on page 172. It is asking you, it is a word problem or an application problem, and it's a compound interest. So if $1,000 is invested at an interest rate R and it's compounded monthly, in 3 years, the amount will grow by the formula that we're given here. We want to find the rate of change and give its units and then just explain that. Okay. So remember, we can rate of change is the derivative, right? And so we want to do that here and be able to explain what it is that that's telling us, right? So the derivative will have the derivative of A over in relation to our rate. Okay, so dA over dr. That equals 1,000 times, so the 1,000, we can kind of ignore that. We're just looking at this and we want to use the extended power rule. Okay, so my K is equal to 36. So that's going to give me 36 times my function here, which is what's in the parentheses, 1 plus r over 12. And this is 36 minus 1, so that becomes 35. Times the derivative of the insides. The derivative of the inside is just 1 over 12 because we're taking the derivative of 1/12 r, right? 1/12 r. The derivative is just 1 over 12. Okay. So now we can simplify this down. And this will give us 36 times 1,000. That gives us 3,600. Yeah. Oh, wait. We have this 12 too. So 36 divided by 12 gives me 3. 3 times 1,000 is 3,000. Okay. 3,000 times 1 plus r over 12 to the 35th. Okay. And the units here are dollars per interest rate. Okay. And so basically, what this is telling me, this is the rate of change in the amount as the interest rate are changing. Okay. Question. All right. So that is all of this section. What I want to do is let's take a quick 10-minute break. So it is 7:42. So let's come back at 7:52 and we will continue with the final section. Okay. All right, it is 7:52, so let's go ahead and continue with section 8. In this section, we're going to start looking at higher order derivatives. It begins on page 174 in your textbook if you're interested in following along. In this section, we will learn about derivatives of higher order. We'll also learn how to find velocity and acceleration from a given distance formula. So first, the derivative f prime, right, that f with the tick mark, is itself a function that can be differentiated, right? So for y equals f of x, the derivative y prime is equal to f prime of x with respect to x. And it's written, so we have y prime is equal to f prime of x, okay? And if I wanted to take the derivative of a derivative, that's called a second order derivative or the second derivative, okay? So the first definition we have up here is velocity. So you can see the velocity is v of t, which is the same as s prime of t, which is the same as if I took the limit of my so I have my S out here is the only thing that's different, that is S of t plus h minus S of t over h. So that really is just our quotient difference, which is what we've been seeing, okay? And so this right here, this formula velocity is really when you think about speed, right? And then the definition here where we're saying acceleration is the derivative of v of t, which means it's the second derivative of s of t, okay? And this one right here really just represents the rate at which velocity changes. And so you could think of that in terms of that is a second derivative, okay? So let's look at a couple of examples. This first one here is looking at taking the second derivative of x to the 4 minus 7. Okay, so you have to take the first derivative, right? So y prime, the first derivative gives me 4x cubed, right? So if I want to know what the second derivative is I really just take the derivative of the derivative. So that is, I could put that as a double tick. And so 4 times 3 is 12. X raised to the 3 minus 1 is 2. So my second derivative is simply 12x. Okay, questions? So this next problem, we want to find the second derivative of y equal to the square root of x. Well, remember, back to the things that we have tools for, it's a little harder for us to just pull out of the hat something for a square root of x, but we can rewrite this as x raised to the 1/2, and now we have it raised to an exponent, and it's easier for us to derive. So the derivative would be 1/2 x, this is the 1/2 minus 1. That's the same as 1/2 minus 2 over 2. And so this is going to give me a first derivative of 1/2 x to the negative 1/2. Okay. That is, we would then put that as 1 over 2x to the 1/2 and put that into radical form. 1 over 2 square roots of x is the cleanest way to write that out. Now, when I go to do my second derivative, though, we really want to just come back to this point here because it will make the math of the problem a little bit easier. So when I take the second derivative, okay, that is negative 1/2 times 1/2. So that gives me negative 1/4. And this is x negative 1/2 minus 1. Remember, minus same as 2/2. So we have a common denominator. And so that's going to give me negative 1/4 x to the negative 3/4. I mean, not 3/4, 3/2. And I could write that in to the denominator as well. So that would be negative 1/4x to the 3/2, which is negative 1/4. The 2 is on the bottom, so that is here. So we don't have to write that. That's square root. And so this is x cubed. Okay, question. All right. So here again, we're asked to find the second derivative. So by looking at the first derivative, we have f prime is equal to 2 times negative 2 is negative 4. X to the negative 3, because that's negative 2 minus 1. That is the same as negative 4 over x cubed. Okay. When we take the second derivative, we'll go ahead and do it off of this one here where it's up in the numerator, because if we do it off of here, you'll get the exact same answer, but you'll have to use the quotient rule, which takes quite a few more steps than just doing the product rule. So we'll have negative 4 times negative 3, which is positive 12. X minus 3 minus 1 gives me a negative 4. So when I write this in proper form where my exponents are all positive, I get 12 over x to the 4. Okay, questions? Okay. Now here is a problem where we'll have to use the quotient rule, right? But we want to find the second derivative. So the first one, we have our f function is 2x plus 3. My g function is 5x minus 1. So f prime equals 2 and g prime equals 5. Okay. So my y prime equals my gf prime minus fg prime over g squared. So this equals 5x minus 1 times 2 minus 2x plus 3 times 5 divided by 5x minus 1 squared. When we simplify our numerator, we get 10x minus 2 minus 10x minus 15 divided by 5x minus 1 squared. Simplifying our numerator a little more, we end up with negative 17 over 5x minus 1 squared. Let's go ahead and put that in a term because we want to do our second derivative, and if we leave it in this form, then our f function is negative 17, our g function is this 5x minus 1 squared. So, but if we rewrite this as negative 17 times 5x minus 1 to the negative 2, we can now use the extended power rule instead of having to use the quotient rule, which would also use the extended power rule. Okay, so it'll save ourselves some steps. So the second derivative here then is going to be, we can write that negative 17 because we're really only doing the extended power rule on this. We'll just carry the negative 17 over with that. So our k here let me do this in another color. Our k is equal to -2. So I'll just do a bracket. So we have -2 for our k times our function 5x minus 1. -2 minus 1 is a -3. And then the derivative of the insides is 5. Okay. So this gives me -17 times -2 times +5. That's going to give me a positive 170 times 5x minus 1 to the -3. Let's bring that exponent to proper form. So we need to make it positive. So that's going to give me 170 over 5x minus 1 to the +3. Okay. Question.
Professor, can you go over again for the second part, please?
Yeah. So which part?
This one, the
blue one?
Yeah, the blue one.
Okay. So, go ahead.
No, just thank you.
Okay. So what we're saying here is just as if I had 5 times x squared, right? We can think of this out on its own and only look at the derivative of the x squared, right? And so if I do that, that's really like 5 times 2x. And then we multiply these. So that's all I was doing here is saying, let's save that -17 till the end, and it won't change it any bit of our problem. But that way it leaves us here with what I have boxed in the blue to do our extended power rule. Because remember, the extended power rule was if we have the form, I could pull that back up real quick and show you the extended power rule was of this format, right? So if we have this, we want to take the derivative of this, it is equal to this, where we have the k. So in this case, that was our k was 3. No, our k was -2 in this case. So that's why we ended up with -2 times the g function, which the g is only what's inside the parentheses. So what was inside the parentheses was 5x minus 1, and then k minus 1 up here, and then the derivative of this inside. So that's all we were doing for that problem was the extended power rule. Did that help?
Yes, thank you, Professor.
So this right here is the extended power rule. Okay. Did I have somebody else that was going to ask a question? All right. So this next problem that we're going to look at is we're going to look at the fourth derivative, right? So that's what this little 4 here is. That's telling us that we want the fourth derivative. Okay, so that means I have to take the derivative and then the derivative and then the derivative and then the derivative. Okay, so first of all, let's just look at the first derivative. So the first derivative is going to give me -2x to the -3 plus, because we have -1/2 times yeah, -1. Oh, this is just a positive. Sorry. So -1/2 times -1 gives me -1/2 x. I have 1/2 minus 2 over 2, so that's going to give me a negative 1/2 here. Okay. Anybody have questions about the first derivative? Now we want to take the second derivative. Okay. -3 times -2 is +6. And then we have x, -3 minus 1 is -4. Now we have -1/2 times -1/2, that's +1/4. Then we have x, and you have -1/2 minus 2/2, that's going to give me a -3/2. Okay. Then we have our third derivative. You could write 3 ticks, or you could put in parentheses here a 3, which is a little bit cleaner. So -4 times 6 is -24. X minus 5. Now we have -3/2 times 1/4. That gives me a -3/8. Then I have x, -3/2 minus 2/2 is going to give me a -5/2 as my exponent. And then lastly, it wanted the fourth derivative. So we'll do it one more time. Take the derivative. The fourth derivative is really just the derivative of the third derivative. So -5 times -24 gives me a positive 120, x to the -6. And then -5/2 times 3/8 is positive 15 over 16. And then this is going to be x to the -7/2. Okay. And since this problem started with negative exponents, we can leave our answer with negative exponents. Questions? Okay, the last problem for this section is an application problem. And so we're given that S of t is equal to -10t squared plus 2t plus 5. And we're asked to find the velocity, the acceleration, and then we want to evaluate each of those when at time equal to 1. Okay. So remember, our velocity is, or our v of t is equal to s prime of t, right? And our acceleration is our v prime of t, which is s double prime of t, okay? And so for this problem, when we want to look at our v of t, remember that's just the derivative of the problem we were given. So that's going to be -20t plus 2. And then when we want to look at the derivative or our acceleration, or a of t, that is just the second derivative of the problem we were given, or the derivative of the velocity that we just calculated. So the derivative of this function is simply -20. Okay. And then so this was part A, this was part B. Part C asked us to evaluate v at 1 and acceleration at 1. So when we plug that in, we end up with -20 times 1 plus 2 gives me -20 plus 2, which is -18. And so that's going to be 18 meters per second for our velocity. Our second derivative, though, is just the derivative of our acceleration function. You could see there's no t value here, so it's just simply -20, and then that's going to be meters per second squared because it is our second derivative. And acceleration, so velocity is single units, acceleration is squared units. Okay, questions? All right. So that takes us to the conclusion of the new material for chapter 1. What I want to do is let's just take a break until 8:20 p.m. so I can get switched over to the exam review, and you guys can stretch your legs, get ready, get your minds ready for that, and we will cover the exam review starting at 8:20. Okay. All right, it is 8:20, so let's go ahead and finish out with this exam review. So a few items to just review about the exam. The exam is going to be next Monday, September 18th. It will open at midnight, close at 11:59 p.m. You get to choose the 100-minute window that fits best in your schedule, right? So once you open it, you have 100 minutes to complete it, and then it times out. The one thing I will say is you need to make sure and start the exam before 100 minutes. So I think 10:20 p.m. if you want to be able to have at least the whole 100 minutes on the exam. Otherwise, if you start the exam at 11 p.m., you're only going to have 59 minutes to work on it. Okay. So it's important that you budget your time appropriately. We will not have class lecture on Monday. That gives you the opportunity to take the exam during our regularly scheduled class time, if that's the only time you have available in your schedule. The other thing that I have underlined here is you must show your work in order to receive credit. If you don't show your work, then you are not going to receive credit on the exam. So again, just make sure that you are showing your work, and you will receive credit and at least some partial credit if you attempt the problem and are somewhat on track, but maybe not 100% correct, then I do have the ability to give some partial credit as well. Okay. All right. On the day of the exam, I will post an announcement. The announcement will go out at midnight. It'll have a link to not only the exam, but it'll also have a link to where you can upload your work. You can also access both of those from the assignments tab in the left-hand pane in Canvas. Okay. So you'll have two avenues to get to that problem. Okay. All right, so let's look at the review itself. So there will be 20 questions on this first exam, and I'm going to go over some example type problems, right? So I did see in the chat that said if there will be an example study guide or an online study guide. So what I suggest is you take this, you look at, so I tell you this here is from section 1.1, number 48. So when you go to that section in the textbook, you can see that that is similar to problems 41 through 50, because that is the type of problem that falls out of this. So if you want more to practice outside of this study guide here, you would refer to the textbook. I would highlight that you should probably work the odd problems, because you can get the odd solutions in the back of the textbook. Okay. You can access your textbook, the e-textbook, from my math lab, just as you do your homework. Okay. So for this first problem, what it's asking us to do is it wants us to determine if the limit exists for this function as x approaches 1. Okay. So a couple of things that I would point out on this one is the first thing we want to do is let's determine what is the limit as x approaches 1 from the left of our function. Okay, so we're thinking about that, and as my function gets closer and closer to 1, here is this value of 1, right? So from the left, as I'm coming in here and approaching left, right, That is, I'm on this equation here, and that works, okay? But as I approach 1, what is my y value? My y value is equal to 4, okay? Also, if I want to determine what is my limit as x approaches 1 from the right, that means I'm coming here as I'm approaching 1 from the right. I am coming up really close here where my y value is 2. Okay. And since these two values are not equal, then we can say that the limit as x approaches 1 of this function, h of x, does not exist. Okay. Questions? Okay. Same page, same type of problems. This is still section 1.1, problem number 66. So for this one, we're given a function and asked to find the limit as x approaches 3, and then again as x approaches 4. Okay. So we have the limit as x approaches 3 of 2 over x minus 3. Okay. So for this one, all we have to do is substitute in our x value. So this is 2 over 3 minus 3, which is 2 over 0. That is undefined. Therefore, this limit does not exist. Okay. Similarly, if we wanted to determine the limit as x approaches 4 of the same problem, 2 over x minus 3, that is 2 over 4 minus 3, which is 2 over 1, which is 2. So the limit as x approaches 4 is going to be 2. Okay, questions? Okay, so for this one, we want to know what's the limit as x approaches 5 of this function. So we just need to substitute 5 in here for the function. And we have 5 squared minus 6 times 5 plus 9. So that's going to give me 25 minus 30 plus 9. So that is a value of 4. Question. Okay. This next problem comes out of section 1.2, number 26. So what we'll see here is when we plug this 2 in, we end up with 2 cubed minus 8 over 2 minus 2. So we end up with 0 over 0, which that's our indiscriminate or our indeterminate form. So we have to factor the original and then take the limit. Okay. So when we factor our original, we end up with the limit of x as x approaches 2 of x minus 2 times x squared plus 2x plus 4 over, this ends up, like, we can rewrite this as a negative. So if you have negative x, let me do that over here. So if I have 2 minus x, right, that becomes a negative. If I factor a negative out of each of those, a negative, negative 2 plus x, and I can rewrite that then as negative x minus 2. Okay. And the reason we want to do it in that form is so that we can cancel the x minus 2 in the numerator with the x minus 2 in the denominator. Okay. So that leaves us then here with the limit as x approaches 2 of negative x squared plus 2x plus 4. When we substitute that in, we end up with negative 2 squared plus 2 times 2 plus 4. And so that is a negative 4 plus 4 plus 4, which is 12. Okay. Question. And I did put over here, just as a refresher for you all, when you're taking a perfect cube and you're factoring it, that is how we're factoring that. So that's how I got that first factor in there. Okay. None of that will be given to you on the exam, so you have to remember how to those factoring techniques. Again, remember, no formulas will be provided on the exam. No cheat sheets are allowed. All of this has to come from your memory. Okay, question. Okay, so for this next one, I put a little reminder here. We need to take the highest power of the denominator. So in this case, our highest power of the denominator is this x cubed. So we're going to divide everything, all terms, by x cubed. And so this gives me the limit as x approaches infinity of x to the 5 over x cubed. Then we have x cubed over x cubed plus 4x over x cubed plus 10 over x cubed. Okay. This is going to simplify down to the limit as x approaches infinity of x squared, right? Because if I take this, and move it up here, that's a -3. So 5 minus 3 is 2. So that's how we end up with the x squared. And then this becomes a 1. This drives to 0. This drives to 0. So that's like 1 plus 0 plus 0. Okay. And so really we're looking at the limit as x approaches infinity of x squared. And so that is infinity squared. And so we can't pinpoint that. So we would have to say that the limit does not exist. Okay. Questions? Okay. So for this one, this is out of section 1.3. We want to find the average rate of change for the indicated value of x. And so we're given a g of x function, a x1 and an x2. So the first thing we want to do is find our y1 and y2. So y1 is the same as saying that we're going to evaluate our g of function at x1. x1 in this case is -4. So that is negative 4 squared plus 4 times -4. So that's going to give me a -16 minus 16, which is -32. Okay. So our y2 value is going to be our g function evaluated at x2, which is 0. So that's -0 squared plus 4 times 0. So that is going to be 0. 0 plus 0 is still 0. Okay. So finally, when I want to determine my rate of change, that is my y2 minus y1 over x2 minus x1. So this is 0 minus -32 over 0 minus -4. And that gives me 32 over 4, which is 8. So my rate of change for this function and those two given x1, x2 is 8. Question. All right, this problem here, remember I said there is one problem where you must use the quotient difference the long way to do a derivative. This is it, right? So when you see, I want to know the limit as h approaches 0 of this f of x plus h minus f of x divided by h, that means you must do the derivative the long way. You can always check your work, right, by doing the quick hand, but if you only give the problem based on the shorthand power rule, you will receive 0 credit for this problem. Okay. All right. So we have f of x plus h minus f of x divided by h. Okay. So that equals 5. So the first one for f of x plus h, that is 5. My x is x plus h squared minus 2 times x plus h plus 7. Okay. Now we have to minus my original function, which was 5x squared minus 2x plus 7. All of that divided by h. Okay. So next we have 5 times x plus h times x plus h gives me x squared plus 2xh plus h squared. I'm going to just distribute this -2 to both terms. So that gives me minus 2x minus 2h plus 7. I'm going to go ahead and distribute this -1 to all 3 of these terms. So that's going to give me minus 5x squared plus 2x minus 7. Okay. All of that divided by h. Okay. Now I need to distribute this 5 to all of the terms inside the parentheses there. So that's going to give me 5x squared plus 10xh plus 5h squared minus 10x minus 10h plus 35. And then, oh, hang on. Sorry. This only goes to that piece. Sorry. We don't add it to these. So it's 5x squared plus 10xh plus 5h squared minus 2x minus 2h plus 7 minus 5x squared plus 2x minus 7, all divided by h. Okay. Now we want to simplify our terms, but we can see we have a negative 5x squared, a positive 5x squared. We have a negative 2x. We have a positive 2x. We have a positive 7 and a negative 7. Okay. We can also see that we have an h term in every single one of the things that have remained. So let's go ahead and factor an h out of everything. So if we factor an h out, that's going to leave me with 10x plus 5h minus 2, all divided by h. And now I can cancel the h in the numerator and the denominator. And that's going to leave me with 10x plus 5h minus 2. Okay. Now I have to, so originally I have to take the limit, right? So all I've done is figure out this portion. Now I have to take the limit of that. So a lot of students get confused and they just circle up and say that's the answer, but it's not. I now have to take the limit as h approaches 0 of this here. And that gives me 10x plus 5 times 0 minus 2, which is 10x minus 2. Therefore, the derivative of this is 10x minus 2. And again, we can check that, right? If I use my power rule knowledge, I know that that derivative is 10x minus 2. Okay? Question. So just one last time, this problem here, this one specifically must be done the long way to receive any credit. Okay? So let's look at the next problem. This next problem wants us to find an equation of the line tangent to this graph f of x equals x squared. And we want to do that at the point 3, 9. Okay? So we want to do this at that point 3, 9. So let's first take our derivative. The derivative of this function is going to be 2x, right? And now I can evaluate this function at 3, where my x value is 3. So you could write this. So a lot of times shorthand, we leave that parentheses of x off, but it is there. So we want to evaluate this at x equal to 3. So that's going to be 2 times 3. So that is 6. That means that is my slope. M is my slope. So now I can use my y minus y1 equals m times x minus x1. Okay, again, back from algebra days. So this is y minus 9 because we were given the 0.39. So my y is 9. My slope we calculated at 6, and my y value was given at 3. Okay, so this is y minus 9 equals 6x minus 18. And when we move the 9 to the other side, we get 6x. We're adding 9 to both sides. 6x minus 9 would be our solution. Okay, questions? So this next problem is like there's a handful in the textbook that you can practice with. So this one is, if you think about putting, we want to know what values of x are not differentiable. Again, remember that's when we see corners or the graph is discontinuous. So for the first one, if I circle the corners, I can see this graph there's a sharp change in direction here, here, and here even, right? And here. So all 4 of these have corners, so they're not going to be differentiable. I can also see there's a corner here, so that's not differentiable. And I can see there's a corner here, so that's not differentiable. This one isn't a corner exactly, but I'm going in one direction and then I change directions. So x6 is also not differentiable. Okay. For the discontinued, where there's a jump in the graph or where there's asymptotes, things like that, that's where we're going to be discontinued. So you could see there's a jump right here in the graph. So that is, we're going to go ahead and be discontinuous here. You can also see that this asymptote here, so there's discontinuous jump in the graph here as well. And so x7 would not be. So really in this graph, there's only 2. There's this piece right here where it's solid and this part of the graph right here where it is solid. So there's only 2 of the values on this graph that are continuous and differentiable. Okay. And so for this problem on your exam, there won't be any work required. You'll just want to write the values on your paper. Okay, question. Okay, so for the next couple, I don't require work because I think that you guys can do these in your head. Yes, could work be done? Yes, you could say y equals 3 times 10, x 10 minus 1. But I think that you can do all of that in your head and just say y equals 30x to the 9. Okay, question. Okay, so this one doesn't require work either. You can do 3 times negative 5 is, this is y prime, sorry. 3 times negative 5 is negative 15. X negative 5 minus 1 is negative 6. And that's all there is to that problem. Questions? Okay, so for this problem, we're going to, you can do the product rule or you could do the quotient rule. I would suggest doing the product rule and moving that x cubed. I would say move this up. It'll make it easier, right? So we can say that f of x is equal to 4x to the negative 3 over 7, right? We could even write it where the, like this, right? And so when we want to take the derivative of that, that is, we can keep the 4/7 alone and then just take the derivative of this piece here. So that is negative 3. X to the negative 3 minus 1 is negative 4. And now I can do negative 3 times positive 4 equals negative 12 over 7 x to the negative 4. Because our answer had our exponent positive in the denominator, we need to move it back down into the denominator. So we have negative 12 over 7x to the 4. Okay. Question. If some of you chose to do this using the quotient rule, and you would get the exact same answer, and that's completely okay as well. I'm not telling you how you have to, what method you have to use, other than that one problem where I require you to show the quotient difference. Okay? Question. Okay, so for this next problem, we want to find f prime and evaluate it at 10. Okay, so we take the derivative first. So the derivative is 2x plus 4. And now we evaluate it at 10. So that's 2 times 10 plus 4 equals 20 plus 4. It's 24. Question. Okay, so here we're taking two functions, multiplying them by one another. So for this one, our first function, f is equal to 5x squared plus 4x minus 3. And our g function is 2x squared minus 3x plus 1. Therefore, f prime is 10x plus 4. And g prime is 4x minus 3. So we'll use our derivative g prime of, so the derivative of our function here is fg prime plus gf prime. So we have 5x squared plus 4x minus 3 times my g prime, which is 4x minus 3, plus g, which is 2x squared minus 3x plus 1, times f prime, which is 10x plus 4. Okay? Now let's multiply all of that out. We end up with 20x cubed minus 15x squared plus 16x. Let's see. Yep. 16x squared. Then we have minus 12x minus 12x plus 9. Now we're on to the second set of terms. We have 2x times 10x, so that's plus 20x cubed plus 8x squared minus 30x squared minus 12x plus 10x plus 4. Okay? So now what we want to do is combine all of our like terms. Okay? So first we have the cubes. We have here's the cubed and here's the cubed, right? We also have here's a squared, here's a squared, here's a square, here's a square. Okay? We have x, x, x term, x term. And then finally, we have constant. It's too close. Let's go. We have a constant and a constant. So we want to add up all of those terms, and we'll end up with 40x cubed minus 21x squared minus 26x plus 13. Okay? Question. And you must simplify all the way down on the exam or you'll lose points. Okay? So this next problem is you looking at doing the quotient rule, right? So my f function is 3x to the 4 plus 2x. My g function is x cubed minus 1. So f prime equals 12x cubed plus 2, and g prime equals 3x squared. So my quotient function is gf prime minus fg prime over g squared. So that gives me x cubed minus 1 times 12x cubed plus 2 minus 3x to the 4 plus 2x times 3x squared. All of that divided by g, which is x cubed minus 1 squared. Okay? So now we just need to do our FOIL method to get all of these distributed. That's going to give me 12x to the 6th plus 2x cubed minus 12x cubed minus 2 minus, that's going to be 9x to the 6th plus 6x cubed all over x cubed minus 1 squared. So we want to distribute this -1 to both of those terms. That's giving me 12x to the 6th plus 2x cubed minus 12x cubed minus 2 minus 9x to the 6th minus 6x cubed all over x cubed minus 1 squared. Like we did in the previous problem, we have x to the 6th x to the 6. We have x cubed, x cubed, x cubed. And we have a constant. So we want to combine all of those terms. And we get 3x to the 6 minus 16x cubed minus 2 over x cubed minus 1 squared. Okay, question. All right, so moving on to the next one. So for this problem, we are looking to do the extended power rule. You could do this you could do it in two ways, right? You could use the extended power rule, or you could break it up and do the product rule. So if we let this be 3x squared minus 4x plus 5 times 3x squared minus 4x plus 5, we could use the product rule here. If we did that, then f is equal to 3x squared minus 4x plus 5. But g is also, right, 3x squared minus 4x plus 5. So my derivative, f prime, is going to be 6x minus 4. And my g prime is also 6x minus 4. So y prime equals f g prime plus g f prime. So this gives me my f is 3x squared minus 4x plus 5. G prime is 6x minus 4. Plus my g prime, or my g, which is 3x squared minus 4x plus 5. And my f prime, which is 6x minus 4. Okay. So ultimately, I actually have two 3x squared minus 4x plus 5 times 6x minus 4, right? So you see that I have one of them, I have two of them, right? So the next thing I can do is I can see that there is a term of 2 in each of these. So I can bring a 2 out of that, and that leaves me with 3x minus 2. Okay. So the rest of this is 3x squared minus 4x plus 5. All I have to do now at this point is take these two 2's, that makes a 4, and then 3x squared minus 4x plus 5 times 3x minus 2. That's it. Question. All right, so for this one, let's go ahead and take that radical and make it into an exponent. So this is 1 plus 8x raised to the 1/2. We want to differentiate this. So that gives me, if I want to do that, y prime is d dx of this f of x raised to the k. So we're using our extended power rule here, which is, remember, it's just k times my f of x function, and then k minus 1, and then multiply by the derivative of my f function out there. Okay, so something to consider, my f is equal to 1 plus 8x. So my f prime is equal to 8. The other thing to consider is that my k is equal to 1/2. Okay. So when we go plug all of that into our function here, we get k is 1/2 times my function, which was 1 plus 8x, raised to the k, which is 1/2 minus 1. So that's going to give me a negative 1/2 times 8. Okay. So 8 times 1/2 gives me 4. So I'm just multiplying those two. That gives me 4. And then I have 1 plus 8x raised to the negative 1/2. To move that down into the denominator. So that is 4 over 1 plus 8 to the positive 1/2. And now let's just convert that back into a square root. And so that is 4 over 1 plus 8. And that is the square root. Oh, 8x. Sorry, I dropped the x off of that second to the last step. Okay, question. All right. So for this problem, we are looking at using the extended power rule twice in conjunction with the product rule. Okay. So my first function is my f is 3x minus 1 to the 7th. My g function is 2x plus 1 to the 5th. Okay, so when I take the derivative of my f function, that is 7, 3x minus 1 to the 6th times 3. Okay, we could simplify that and say that's 21, 3x minus 1 times 6. So that's just 3 times 7 gives me that 21. Then my g prime function then is going to be 5 times 2x plus 1. 5 minus 1 is 4. And then the derivative of 2x plus 1 is 2. I can also simplify this. 5 times 2 is 10, and 2x plus 1 to the 4th. Okay? So when I want to do this, this is the product rule. So g prime is fg prime plus gf prime. Okay? So we have 3x minus 1 to the 7th times 10. I'm going to put that in a bracket since there's a parentheses here. 10, 2x plus 1 to the 4th plus 2x plus 1 to the 5th times 21, 3x minus 1 to the 6th. Okay. So very similar to a problem we worked a little earlier tonight where we're factoring out common terms. I have this 3x minus 1 with an exponent of 7, and I have 3x minus 1 with an exponent of 6. So I'm going to bring 3x minus 1 to the 6th out and factor that out. I also have this 2x plus 1 to the 4th and 2x plus 1 to the 5th. So let's factor 2x plus 1 to the 4th out. Okay. And now we're on to what we have left. So when I factor that out of the green one in this first term, I will show you this is what we're gonna factor out 6 of those. So we're bringing back just one of them on the inside. Okay. But we're also bringing on the inside this 10. So I'm actually going to slide this over, And let's put the, let's put the 10 in there. Okay. And I factored out all 4 of the purple ones, so there's none left. Okay. So now let's move on to the second piece. So we're adding, I factored 4 of these 5 purple ones. So that leaves me with 1 of them and the 21. So I'm going to bring the 21 here and 2x plus 1 because we factored out all 6 of the green ones. Okay. All right. So now let's just simplify. So we have 3x minus 1 to the 6th, 2x plus 1 to the 4th. Now this is 3 times 3x gives me 30x minus 10 plus 42x plus 21. And the last thing we need to do is just simplify what's inside of these brackets here. So we have 30x and 42x, and we have a negative 10 and a positive 21. So when we do that, we have 3x minus 1 to the 6th, 2x plus 1 to the 4th, and this simplifies to 72x plus 11. Okay? Question. All right, on to the last section in our textbook. This one is looking at the second derivative. So you'll want to pay particular attention when it asks you to do those because you'll want to make sure if it asks for the second derivative that you're actually giving it the second derivative. So my f function is 2x plus 3, and my g function is 5x minus 1. F prime equals 2, and g prime equals 5. So we have to use our quotient rule. So this is g f prime minus f g prime over g squared. So this is going to give me 5x minus 1 times 2 minus 2x plus 3 times 5 divided by 5x minus 1 squared. We have to distribute this negative to all of these terms. This is going to give me 10x minus 2 minus 10x minus 15 over 5x minus 1 squared. Okay, when I simplify that, I get negative 17 over 5x minus 1 squared. It's a little harder. I don't want to have to do my second derivative like this. So let's just rewrite this as negative 17 times 5x minus 1 to the negative 2. And now I can do my extended power rule on this, where my k is equal to negative 2. My f is 5x minus 1, and my f prime is 5. Okay, so when I'm looking at my second derivative, then, so my second derivative is going to be this negative 17. We're just going to leave that be. My k, which is negative 2, times my function, 5x minus 1, k minus 1, so negative 2 minus 1 is negative 3. And the derivative of my function is 5. Okay, so we simplify all of that, we get 170 times 5x minus 1 to the negative 3. And we can then rewrite that as 170 over 5x minus 1 cubed. Okay, question. All right, one more problem. So this one, I'm asking you to give me the sixth derivative of the function, okay? If you only give me 5, that's not right. You have to give me the value or the number that I'm asking for, okay? So my first derivative is going to be 7x to the 6th minus 16x. My second derivative is 7 times 6, which is 42, x to the 5 minus 16. My third derivative is 42 times 5, 210, x to the 4. My fourth derivative is 210 times 4, which is 840, x cubed. My fifth derivative is 3 times 840, that's 2520, x squared. And finally, my sixth derivative, 2520 times 2 is 5040, x. And so my sixth derivative of x to the 7 minus 8x squared plus 2 is 5040, x. Okay?
Professor,
Yes.
how is it that you got I got lost from 42 all the way to 210?
Yep.
So how did you do that?
42 times 5 is 210. So the derivative of this, 42 times 5 is 210. And then you just decrement. So it's really, because remember, the second derivative is the derivative of this. The third derivative is just the derivative of this. The fourth derivative is just the derivative of this, and so on. Does that help?
Yeah, so technically, so it would mean I would just have to multiply like 210 times 4, correct? To get
Correct.
the answer for, okay, thank you.
And then you decrement the exponent by 1. Okay, questions? All right. If you guys do not have any other questions, that is all the material I have for you tonight. Remember, exam 1 next Monday, so we will not have a class meeting on Monday. You will just do the exam. You'll have 15 minutes to upload that into Canvas. It's very similar to the homework that you guys have to practice uploading papers. Again, you can take pictures of all of your work and save that into one document and upload that. You can scan your work in, whatever is convenient for you. That's why we have that practice assignment, so that you can work out all those kinks before the exam day. Okay, if you guys don't have any other questions, that's all the material I have for you. You're free to go, but I'll stick around in case you have any last minute questions.
Wait, how many questions are there gonna be?
20.
Okay, thank you.
You're welcome.